So today we want to look at the solutions for quiz 5. And so the first question has this information. N of the universe is 100. N of A, the set A is 24. B is 60. The intersection is 10, and I want to find the cardinality of A intersect B complement. So when I look at this problem, this has two sets. I really need a Venn diagram just with two sets. And you can do this in a variety of ways. Sometimes it helps to start with the simplest piece of information. So for example, here, I know that this intersection only refers to one of these regions. That's right here, N of A intersect B. So I can fill in that information. Then I know that N of B is 60. That's these two regions, which sometimes I denote by writing on this line, but that also implies that this region should be 50 over here. The whole set A is 24. That's these both regions, so this piece should be 14. And then, so I use that, and I use that, and then the totality is 100. So I have 50 plus 10, that's 60. Plus 14, that's 74, and 100 minus 74 should be equal to 26 out here in the outside in the actual universe. So then the question, the cardinality of A intersect B complement, that's the stuff that's inside A and outside B, so it's right here. That region, and your answer should be 14. Oops. Wrong pen. Problem 2 should be very similar. But it's a word problem. So a certain jewelry store has 1,000 customers, each of whom buys gold or diamonds. So I have gold or diamonds for this Venn diagram. And 645 by gold and 240 by gold and diamonds. So 240 by gold and diamonds, that's here. 645 by gold, that is both of these regions again. 645 gold and diamonds. Gold. It's this whole circle. So that means this region over here should be 405. And then I have to go back, how many, because I want to figure out how many buy only diamonds. And I go back to the first line and it says a jewelry store has 1,000 customers, each of whom buys gold or diamonds, which means all of the 1,000 people are inside one of these two circles. So these three regions should add up to 1,000. So that means that this region should be 1,000 minus this total 645. So this should be the 1,000 customers minus the other two regions, which is 355. So part A, how many buy only diamonds? That's 355 customers. Part B, how many buy something other than gold or diamonds? That is not given in the information, or like we're only talking about the 1,000 customers that buy gold or diamonds, so this answer should be 0. Problem 3, 4, and 5 all are the same, and we'll make one Venn diagram for them, so I'll make that here. We'll answer the questions. So it talks about job applicants and characteristics of the applicants. And the 3 characteristics are female, college graduates, and also bilingual. And again, this is one of those examples where it helps to start at the end of this description. So it talks about 11 are female. That would be this entire circle, all 4 of these regions. College graduates would be all 4 of the regions here. But if I go to the end, 2 are bilingual, female, college graduates. That's this intersection. They're bilingual, they're inside this circle, they're inside the female circle, and they're inside the college graduate circle. That's right here. Is this last 2 are bilingual, female, college graduates. And I go back to the next to last description. 6 are bilingual college graduates. So this number 6, bilingual college graduates, should be this intersection here. And if I'm writing the 6 on this line, it goes right here. Maybe I'll draw it out. That's the 6 is both of these regions. So that means this, if the far interior region is 2, this one has to be 4 for this combined to be 6. 2 are bilingual women. That's these 2 sections. Since I have 2 people here, then that means this one is 0. 3 are female college graduates. That's this intersection. And I have 3. That's 2 plus 1 should be in this other region. 7 total are bilingual. So I have 6 already. 1 more makes 7. 17 are college graduates, and I have 7 people in the college graduate region already, so I need 10 more out here. And 11 are female, and right now I have 3, so that gives me 8 in that region. And then we want to answer these 3 questions. The question for problem 3, how many college graduates are male? Male college graduates is everybody in this group. Let's make sure, because we have 30 job applicants, so let me make sure, because I want to fill in this universe. So let's count up how many I have. I have 8, 9, this makes 19, 21, this makes 25, and 26. I think I have 4 out here. Let me do it. I'm going to do it real quick again on my calculator just to make sure. Yep, I get 4 out there. Okay. So, but the question is, how many college graduates are male? So I'm looking in this section inside this circle, but outside the female circle. So it should be this region here and this region here. That denotes people who are college graduates but not female. So it should be 14. Okay. Problem 4 uses the same information. So we'll look at that. The question says, how many female college graduates are not bilingual? So I have female college graduates, that's here, And not bilingual is just this one right here, because these two are bilingual. So I have 3 people who are female college graduates. Not bilingual is just this one person. So female college graduates, not bilingual. Is just one woman. And problem 5, how many women who are not college graduates are bilingual? So I'm looking at females who are not college graduates. That's these 2 regions, 8 and 0 combined. And I want to know how many are not bilingual. So female, not a college graduate, and are bilingual. Should be this total 8, who are bilingual. So how many female women, not college graduates, are bilingual? It's this number here, 0. Problem, 6. 6 begins kind of these counting problems. A shirt company has 3 designs that can be made with short or long sleeves, and there are 5 color patterns available. How many different types of shirts are available? So, in a lot of ways, I always think of like trying to fill in how many possibilities there are for each of the choices that I have. So there are 3 designs, sleeve length, there are 2 sleeve lengths, and color patterns. There are 5. To get the total number of possibilities, I multiply in here. 3 times 2 is 6 times 5 should give me 30 possibilities. Okay. Similarly, for problem 7, an exam contains 5 questions. So I get 1, 2, 3, 4, 5. Like this is question 1, question 2. And each has 4 answers, so there are 4 possible choices that I can choose. And again, the multiplication principle says that this should be 4 to the 5th power. Okay. Problem 8. How many 4-digit codes can be formed using digits 0 through 9 if the last digit, and I have a condition, but I know that the code is 4 digits. Digit 1, 2, 3, 4, there's an ordering here. And I want to put in this condition first. It says the last digit cannot be 0, 1, or 2. And that leaves me, there are 10 total digits, 0 through 9. And when I remove those 3, that leaves me with 7 in this last possibility. Now I want to fill in how many possible choices I have for each of these other 3 spots. Repetition is allowed, so I have 10 choices here. I can repeat, so I still have 10 choices here and 10 here. So I should get 10 to the 3rd, or 1,000 times 7, which should give me 7,000. 9. There are 6 roads connecting town A to town B. So A to B. Oops. A to B. That route, there are 6 possibilities. And going from B to C, there are 7 roads. And again, I can go any of these 6 ways, and then I can choose any of these 7 ways. So in the question, how many ways can a person travel from A to C if I have to pass through B? That should be this 42 ways, 6 times 7. 10. Toss a coin 7 times. What is the number of possible sequences of heads or tails? Again, you have 7 slots that you fill in. 1, 2, 3, 4, 5, 6, 7. Each one can be heads or tails. There's 2 possibilities in each of these slots. So I get 2 to the 7th power.